Hello and welcome back. We're going to take a look at negative exponents, and we're especially going to look for a pattern when we encounter negative exponents. So in the top chart, I just wanted to go through what's going on here and what pattern is occurring. So notice in our expression here, it goes 10 to the third, to the second, to the first, to the 0 power, -1, -2, -3. So this is going in a pattern here. So moving across 10 to the third, if we expanded 10 to the third, that means 10 times 10 times 10. And 10 times 10 is 100, and 100 times 10 is 1,000. Also notice the simplified form is a 1 with 3 zeros, and our exponent has a 3. Moving on in the table, 10 to the second power, that means 10 times 10, which is a 1 with 2 zeros, which is 100. So what happened between 100 and 1,000? What happened was it got 10 times smaller, or divided by 10. If we continue that pattern, 10 to the first power is just 10. So that's just a 1, 0. See, the exponent's 1, we have 1, 0. And if we went from 100 to 10, that's also dividing by 10. Now we also learned that anything to the 0 power is 1. And notice it's a 1 with 0 zeros. See, to anything to the 0 power is 1. And if we continued this pattern, 10 divided by 10 is 1. Let's take a look into the negatives now. 10 to the -1, we learned that we can make a negative exponent into a positive fraction. So just by taking the 10 and putting it into the denominator, which is the same as 1/10. Now if we did 1 divided by 10, we would get 1/10. So the pattern continues. So let's go on to the next one. 10 to the -2. That means there's a 10th times a 10th. There's 2 of these bases, and that's 1/100th. Again, we are simply dividing by 10 again, which is 1 over 100. And the final one, a 10 to the -3, right here, that means we have a 10th times a 10th times a 10th, which is 1,000th. Now, I also wanted to point out to you this 10 to the third compared to a regular 10 to the third. So 10 to the third is just 1,000. So 10 to the -3rd is 1,000 in the denominator. So it's the reciprocal of that. So hopefully you can see the pattern, and as it descends, what happens to the fraction. So let's try another one with a base of 5. And we'll go through the same pattern. So 5 to the third power, if we expand it, that means 5 times 5 times 5. The simplified form, or evaluating it, 5 times 5 is 25, and 25 times 5, that would equal 125. Okay, 5 to the second power, expand it, that's 5 times 5, which is 25. So the relationship from 125 to 5 is just dividing by 5 each time. 5 to the first power is just plain old 5. Anything to the 0 power is 1. And if we did here, 25 divided by 5, we would get 5. And if we did 5 divided by 5, we would get 1. So what's going to happen next? 5 to the negative first power, we just make it a positive fraction. We can take that negative 1 and put it in the denominator. So this is 1/5. Now this should make sense. 1 divided by 5 would be 1/5. 5 to the negative 2, that means we have a fifth and another fifth. So that's going to be 1/25. And 5 to the negative third is 1/5 times 1/5 times 1/5. Okay, so this is 1 times 1 times 1, which is 1. And then 5 times 5 times 5 is 125. So step back and look. 5 to the third power is 125. 5 to the negative third power is the fraction 1/125. So a lot of kids will just look at it that way. They'll just do the reciprocal. So let's suppose we had 2 to the third power. 2 to the third power is 8. So what do you think 2 to the negative third power is? It's the reciprocal of 8. It's 1/8. Do you kind of see how those are the same, but they're the reciprocal? 8/1, then you flip it. What if we had 6 to the second power? That would be 36. So 6 to the negative second power is just a 1/36. See the relationship between these? Okay, so hopefully you start to begin to see the pattern and why it works, and also see, just reinforce that anything to the 0 power is 1. Patterns are everywhere in math, and we especially see them with our negative exponents. Always be looking.